have you on Fascinating Frontiers, episode 140, for July 23, 2026. Let's look at what's new across the frontiers of space and science. A candidate Jupiter-sized moon orbiting far beyond our solar system is forcing astronomers to redraw the line between planets and moons. Astronomers have found evidence for a satellite orbiting an exoplanet outside our solar system through transit timing variations and subtle changes in the host star's light. The candidate object is roughly Jupiter-sized, which challenges traditional distinctions between planets and moons. Further observations with larger telescopes are required to verify the signal and rule out other dynamical effects. The detection method combines transit photometry with dynamical modeling. While astronomers hunt for these borderline worlds at interstellar distances, closer to home, a major telescope has uncovered a hidden giant in a young planetary system. NASA's James Webb Space Telescope has detected a giant planet orbiting within the debris disk of Beta Pictoris. The planet was identified through direct imaging after earlier data sets were re-examined with improved calibration. Its presence helps explain gaps and structures previously seen in the disk by other telescopes. The discovery adds a third giant planet to the system, which is only about 20 million years old. Follow-up observations will measure the planet's orbit and atmospheric composition. From newly revealed planets, we turn to one that may already possess something even rarer, an atmosphere we can study. Astronomers have confirmed an atmosphere on a rocky exoplanet located in the habitable zone of its star. Transmission spectroscopy during transits revealed absorption features consistent with a substantial gaseous envelope. The planet's size and density suggest a composition similar to Earth or Venus. The detection relied on multiple transit observations to separate the atmospheric signal from stellar variability. Additional spectra are planned to identify specific molecules. While we examine distant worlds, back in our own solar system, a long-serving spacecraft is waking up for fresh observations. NASA's New Horizons spacecraft has ended a year-long hibernation to begin new observations in the outer solar system. The craft will study distant Kuiper Belt objects and measure the heliosphere's edge. Instruments will collect data on cosmic rays and dust particles at distances never before sampled. Mission controllers have confirmed all systems are operating normally after the long sleep. The new phase extends the spacecraft's exploration well past its original Pluto encounter. From the edge of the solar system, we shift to preparations for returning humans to the moon. NASA will conduct integrated flight tests of the SpaceX Human Landing System and Blue Origin's Mark I lander before the next crewed lunar landing. The tests will evaluate propulsion, navigation, and docking systems in Earth orbit. Data from these flights will inform certification for Artemis missions. Engineers will compare performance against requirements for crew safety and payload delivery. The schedule calls for the tests to occur ahead of the next planned lunar landing attempt. Researchers in Cyprus have pinpointed specific genes whose expression changes during extended time in orbit. The work analyzed blood and tissue samples from astronauts before, during, and after missions. Results point to pathways involved in immune response and bone metabolism that activate differently in microgravity. The team plans to compare these markers with data from future commercial crew flights. The findings may help design targeted countermeasures for longer missions. Understanding those physiological effects is one goal of NASA's latest call for volunteers. NASA is recruiting volunteers to participate in a simulated year-long mission to the Moon and Mars, conducted entirely on the ground. Participants will live in isolation and follow schedules that mimic communication delays and daily operations. The study will collect data on team dynamics, psychological resilience, and performance under constrained conditions. Results will inform crew selection and habitat design for future deep space missions. Applications are open through the agency's Human Research Portal. From simulation on the ground, we move to an actual long-duration crew member coming home. NASA astronaut Chris Williams is scheduled to land on July 26 after completing 241 days aboard the International Space Station. Coverage will include live views from the Soyuz spacecraft during re-entry and post-landing medical checks. This marks the end of Williams' first long-duration mission. Ground teams in Kazakhstan and Houston will coordinate the handover of station operations to the remaining crew. The return brings the total number of days Williams has spent in space to 241. While one astronaut returns, public events are being planned to witness a rare celestial alignment. The European Space Agency, the City of León, and the University of León are organizing public events around the total solar eclipse. Attendees will hear talks on the physics of the sun's corona and the alignment geometry that produces totality. The program pairs ground observations with data from ESA's solar missions to compare real-time images with spacecraft views. Participants can also join workshops on safe eclipse photography and the historical role of eclipses in testing general relativity. The event runs on the day of the eclipse with viewing sites chosen for clear horizons. From watching the sun, we turn to watching the sky for Mercury's change in motion. Mercury reaches its stationary point at 1 p.m. Eastern Daylight Time while in Gemini and begins direct motion. The planet remains visible low in the eastern sky before sunrise for the next several weeks. Observers can use the date to note the shift from its earlier westward drift against background stars. The event coincides with Dione passing north of Saturn as seen from Earth. Daily sky charts show Mercury's changing position relative to Castor and Pollux. From naked eye observing, we move to a surprising discovery made with radio telescopes. Astronomers have identified a sugar molecule previously found in raspberries within a star-forming region. The detection used radio telescopes tuned to the molecule's characteristic emission lines. Its presence suggests that complex organic chemistry can occur even in cold, dense clouds before planets form. The finding adds to the inventory of prebiotic molecules available during planet formation. Further surveys will search for related compounds in the same cloud. From chemistry in space, we look at living organisms that once circled the moon. Seeds that circled the moon aboard a spacecraft were later planted in Georgia and have grown into trees now listed as endangered. The project tracked how microgravity and radiation affected germination rates compared with control seeds kept on the ground. Researchers are studying whether the space-exposed trees show genetic changes that could help conservation efforts. The trees belong to a species already under pressure from habitat loss and disease. Follow-up studies will monitor growth patterns over the next decade. From biology on Earth, we turn to a robotic system heading into orbit. A recent SpaceX launch delivered Northrop Grumman's two-handed robotic system designed for satellite servicing and rescue operations. The robot will demonstrate capture and repair techniques on defunct spacecraft. Mission planners expect the demonstration to validate robotic arms and sensors for future on-orbit assembly tasks. The payload shares the ride with other commercial satellites. Data from the mission will feed into designs for larger servicing vehicles. From servicing satellites, we move to monitoring them. China's Shijian-31 satellite, launched in June, operates in a specially designed orbit that allows repeated passes over the geostationary belt. The unique trajectory provides extended viewing time of GEO satellites from varying angles. Analysts note the orbit enables continuous monitoring without remaining fixed in one location. The spacecraft carries sensors suited for tracking objects in the crowded GEO region. The mission supports China's space situational awareness efforts. If you shrank the observable universe down to the size of Earth, an atom would be smaller than a single proton in that model. Yet both extremes are described by the same laws of physics. Traveling inward from a galaxy cluster, you cross 100 million light-years, then 100,000 light-years inside a typical galaxy, then a few light-years between stars, then the 1.4 million kilometer width of the Sun. Then the 1.4 million kilometer journey shrinks to the 1.4 meter height of a human, then to the 0.1 nanometer width of an atom, and finally to the 10 to the power of negative 15 meter scale of its nucleus. At each step, the dominant forces switch. Gravity yields to electromagnetism, then to the strong force, and the mathematics that works at one level fails at the next. A single number captures the gulf. The ratio between the Planck length and the diameter of the observable universe is roughly 10 to the power of 61. We can measure both ends with instruments, yet no single theory yet bridges them without contradictions or infinities. New data on exomoons, atmospheres, and outer solar system missions keep adding concrete pieces to long-running questions. Next time, we'll be watching for updates on the Webb telescope's follow-up observations of the newly detected planet in Beta Pictoris. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. Quick tip from the network: try modern investing techniques next. Modern strategies for Canadian and US investors. Every NERA Network show is free at neranetwork.com. Want the written briefing with source links? Each show keeps a summaries page on neranetwork.com, scannable, dated, and free. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through